All right, boys and girls, so there was a question on the post test that was about something that we had never learned before. So I figure better late than never. Let's go ahead and look at number 14. It says, what is the prime factorization of 50 using exponents? Well, we don't know what prime factorization is, but we do know some things. We know that a prime number is a number with only its bookend factors, 1 and itself. And so we did the F's, and we figured out that prime numbers are 2, 3, 5, 7, 11, 13, and so on. There are many, many, many more prime numbers, but those are the first 6. And if you can remember the first 6, then you will be an expert in prime factorization. We know that the word factor means numbers that multiply together to make the product. In this case, our product was 50. And then, of course, we know what exponents are. That's little e, which I'll talk about how that fits into the problem later. So let's talk about prime factorization. I'm going to do some examples for you. So prime factorization is basically giving the factors of a number only using prime numbers. So let's do an example. Let's do the number 40. Okay, if I want to do the prime factorization of 40, there are so many different strategies for prime factorization. My favorite one are called factor trees. Factor trees. And so you know what I'm saying here. And what I love about factor trees is trees have branches and they have leaves. And so we are going to do a factor tree with branches and leaves to do the prime factorization of 40. So here we go. First off, I'm going to get my branches out. And I'm basically going to come up with 2 factors of 40. And my goal is to do anything other than 1 and itself. Because if the only choices are 1 and itself, then 40 is a prime number to begin with, and it can't be prime factorized. I think I just made that word up. So I know another pair of factors for 40 are, how about 5 times 8? I know 5 times 8 is 40. And these are my branches. Now, my leaves happen anytime my branch ends at a prime number. Now, just a reminder that ignore that. Just a reminder about what our prime numbers are. And again, if you can remember the first 6, you're good as gold. We have 2, 3, 5, 7, 11, and 13. So if you know our prime numbers, then you can also see that 5 is one of our prime numbers. So that branch is going to end at that leaf of 5. But 8 is not listed. It's not a prime number, it's composite. So this branch is going to have to get even further branched out. And I need to think about what are 2 numbers that multiply together to make 8. Well, I know that 2 times 4 makes 8. So I know 2 is a prime number, so that's going to be the end of that branch. It's going to be a leaf. And 4 is not one of my prime numbers. So then I'm going to need to branch out this 4 even further. And I know that 2 times 2 is 4. 2 again is a prime number, so my leaf is going to end that branch there. So I know that 40 is 5 times 2 times 2 times one more 2. And I'm going to prove this to you. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. Now that exponents part comes in now. I only have 1 5, so that's going to stay put. But here I have 3 2's being multiplied together. That's some repeated multiplication. And I know that little e means repeated multiplication. So I'm going to write 2 times 2 times 2 as 2 to the 3rd power. So my final answer for the prime factorization of 40 using exponents would be 5 times 2 to the 3rd power. So I'm going to go ahead and do one more for you, and then you're going to try to solve the one from the post test. Let's try 24. Okay, I'm going to start my branches. There's different choices. I can do 6 times 4. I can do 8 times 3. It doesn't matter what your branches are. You're always going to end up with the same leaves at the end. So I'm just going to do about 6 times 4. And neither of those are prime numbers. My prime numbers are 2, 3, 5, 7, 11, and 13 are my first 6 prime numbers. And I don't see a 6 or a 4. So my 6th branch is going to have to get branched out again, I know that 2 times 3 is 6. Well, 2 is a prime number, and so is 3, and so both of those branches are done. 4 is also a composite number, so I need to branch that out. And again, 2 times 2 is 4. 2 is a prime number, and again, 2 is a prime number, and all of my branches have ended at prime number leaves. So my prime factorization would be 2 times 3 times 2 times 2 again. I'm going to prove it to you. 2 times 3 is 6. 6 times 2 is 12. 12 times 2 is 24. Now, of course, I need to do that exponents part. So if I look, I have 1, 2, 3 2's here. So that would be 2 to the third power. So that takes care of those. And then I still have to multiply 2 to the third power times 3. So my final answer of prime factorization with exponents of 24 is 2 to the third power times 3. Now, if you go back to the original question was asking for the prime factorization of 50 using exponents. I want you to give it a try. These shouldn't say 1, 2, 3, 4. These should say A, B, C, D. See if you can figure out which would be giving the prime factorization of 50 using exponents.